Hi, Vishnu.
Hi, sir. Hi, sir. Good evening.
Good evening. Have you tried those questions which I posted in group?
No, sir. I was preparing for my college exams, so I didn't get time.
Okay. Hello, Jan.
Hello, sir. Hello.
Yeah. Today you
Sir,
are joining?
yeah, sir. Today I'm John.
Okay. Great, great. So you're in 12th grade or you completed 12th grade?
No, sir. I'm in 12th grade.
Acha.
Sir, can I know which chapter is going on?
We are doing here ray optics.
Okay, sir.
Ray optics. Today we'll start new topic in that, refraction through prism.
Okay, sir.
Yeah.
Thanks, sir.
Hello, Samhita. You tried those questions which I posted in a group? Samhita,
Yes, sir.
did you try the question which I posted in a group?
The list of questions, sir.
Sorry?
The list of questions you gave.
Yeah.
Sir, I tried a few.
Okay. They were easy, right? They're like basic theories.
Yes, sir.
Yeah. Super. Okay, then let's start. Let's not wait. They'll let them join. Okay, we saw before like reflection through lenses. We saw lenses, half lens, full lens, like whatever different types of lenses. Okay, so we saw like combination of lens, mirror, all those things. So now we'll see refraction through prism. And this one is like pretty easy only. Like as you're studying 10th standard also, like ray moving from rarer to denser, medium, denser to rarer, how it behaves. Same way, like ray moving from rarer to denser medium, this is your changing transition point. So it will change from rarer to denser. Denser is the glass. So it should move towards the normal. This is your normal line towards the normal. Can you guys hear me? Am I audible or not? No, I guess I got disconnected.
Sir, you're audible.
Audible? Okay, super. Then let's continue there. Okay, yeah, as I was saying, it's moving from rarer to denser medium. It moves towards the normal. And then this point, this transition point is denser to rarer. So it's moved away from the point. I mean normal, point in a sense, normal. So what is normal here that everyone knows, right? What is a normal line? How can I draw a normal to this surface?
That's a perpendicular line between two mediums.
Yeah, so as I was asking, how to do normal to this surface? Can anyone tell me?
So it's a perpendicular line.
Yeah, exactly. So it is a perpendicular line to this surface will be normal. The same manner, if it is a prism, it goes same manner. Whatever surface it is, prism or like whatever. So as I'm drawing, is it as it is drawn here also, this is your incident normal ray. So this it's moving from rarer to denser medium, so it will move towards the normal. Actual direction of this ray was this one, but got deviated as it is moving from rarer to denser. And same manner, actual direction of this ray was this, but got deviated again because as it is transition like from denser to rarer. This all you know, right? So like this is your angle of prism. Angle A is the angle of prism here, and this is a delta. Delta is your like angle of deviation, and I and E is your emergent. You can see here. E is your emergent. This is the angle of deviation. This is the angle of incident. So if we take the triangle here, delta plus A is equals to I plus E. Now even we can derive this one also like from normal triangle formulas, all that. This simple like triangle things. You can take some triangle, let me change हो हाँ ठीक है. Let me draw here triangle separately. We can prove it also. All this you can say angle of incident, angle of emergent, this is angle of deviation. And this is angle of reflection 1, reflection 2, like that. Okay, so if, and this is your, yeah, angle of prism. Now, if we like, if we take this triangle and if you see here, this angle here, angle, new student. Yeah, let me check. 1 second, please. Yes, they have joined. 1 second, please. Yeah, sorry. So yeah, as I was saying, this is your angle of prism. This is angle of deviation. If I extend this line here, it moves here. It doesn't matter. Like this, see, these things doesn't matter much. If we take this triangle here, let's take deviation 1 from the incident. This is your deviation 2. Deviation 2 for this emergent. So I can say out exterior angle, if I take this one as exterior, so exterior angle will be equals to sum of this two interior angle plus delta 2. Exterior angle is equals to sum of two interior angles. Now I want this delta 1. Now I can say this whole angle is equals to I. So I minus R1. Same way, delta 2 equals to E minus R2. So if I substitute both things here, I'll get delta equals to I plus E minus R1 plus R2. Is this okay? Yeah. Fine. Then let's take this triangle. This triangle, if I take this triangle, so some of the triangles, angles, and all that are 180 degree that we know already. So let's give a name. This is A, angle A, plus this is, we can say 90 minus R1. This same way plus 90 minus R2 equals to 180 degree. So angle A equals to 180 minus 0, it will become R1 plus R2. So I can say I plus E minus A, angle A. So we can say delta A, delta plus A equals to I plus E. That's what we are proving here. It's very simple, like. Okay. For if we want like delta minimum here, then I should be equals to E. Yeah, by the way, you understood, right? All, everyone? Is this clear?
Yes.
Others? Rituraj, Samhita, Jayan,
Yes, sir.
Vishnu?
Yes, sir.
ठीक है. Okay. This was like, okay, fine. It's not required to write because it's we are studying for competitive. So you just need to know, okay, yeah, how we got this angle. That's it. So if you want to make a note, you can. It's not like, it's not a problem. It's just small notes only. See. Okay, so if we want delta to be minimum, what shall we do here? I should be equals to E, and R1 should be equals to R2. That means it will be so small. So deviation will be almost like least, like. So your graph will follow like this. At this point, I is equals to E. So delta M will be equals to A into mu minus 1. So their formula will form similar way. A plus delta M minimum by 2 divided by sine A by 2. This was a similar way we are doing. Okay, like we are just following same method. If it is R1 equals to R2, then A will become R1 plus R2 means 2R. A will be twice of R, and R will be equals to A by 2. Like same, we are following like, sorry, change pen. Sin I by sin R, refractive index, and 2, 1. Same thing we are following. R will be here, A by 2. And I we need to find out. So what we'll do here, we need to just change it this way. It's the same thing only, like a similar way we are doing. So we got here sin A plus delta M by 2. So this is most important formula here. This formula to be noted. Note this formula. Okay, done. Shall we move to next? Okay. Next is your breaking a white ray of a light into its constituent 7 color. That is called dispersion. Does everyone know that? Dispersion. Splitting of white light into 7 colors. That is Vibgyor. Constituent means that spectrum. Angular dispersion, difference of deviation by red and violet. So first and last. So if you observe this one here, if we follow like a V, I, B, G, Y, O, R. So R is least deviated and V is most deviated. So deviation is higher in this V and deviation is lower in R. Okay, so dispersive, sorry, the dispersive power. It is the ratio of angular dispersion to the mean deviation produced by prism. It is just the ratio of mean deviation. So first violet minus red divided by mean deviation. Next is our some optical instruments. This is most important. These are like, okay, it's very, very easy things. Dispersion and all that. It's very easy. Most important here, that is instruments. Is anyone writing? Shall I scroll?
Sir, I'm writing.
Yeah, okay. Excuse me. Yeah, see, these are whatever we are writing, these are not exact notes for your board exam, okay? We can use this for revision and all that, revising everything, quick revision. Okay. Optical instruments. So like there are so many optical instruments. Like for us, we have microscope, telescope. Yeah, we have only 2 instruments. There are actually so many instruments, but we are not going to use it. We will just use simple microscope, compound microscope, astronomical telescope. Once they were asked this terrestrial telescope also, once or twice in mains. I've seen somewhere. Okay, we'll see that. We'll solve that questions. Okay, first of all, microscope. What is the work of microscope? Can someone tell me what is the use of microscope?
Magnify objects.
Magnify object. Okay, like suppose this object is some smallest object, like micro object, which can be which we will magnify with the lens, which is like simple microscope. And in compound, like what we'll do, we'll make it like double lenses. Okay, not drawn here, but there will be double lenses. So image of the first lens will become object for the second lens. So that will magnify 10. Suppose first lens is magnifying, suppose if I give a number as 10, it is magnifying 10 times. So the next lens will magnify 10 more times. So it will become 100 times magnification. So microscope work is to magnify the smallest object, that is like we can say whatever smallest object, we can do it here. But see, we cannot go with that much smallest like electron and all that. That is different now. Electronic microscope are different. It is not similar as whatever microscope we are going to study for now. Okay, so simple microscope, if I draw it here, as it's already drawn, but let's draw it here again. So this is your lens. Okay, so our object is placed somewhere here. That will be, as our rules follows, it will be magnified here. It will be magnified here. Okay. So like as it is name given here, whatever height of this object. So this will magnify on the same place. As you know, these rules for this lens is like all the rules. It is diverging. So these rays are diverging here, so it will never meet. If it is parallel rays, if these rays are parallel, it will meet somewhere at infinity. We say that. But if it is diverging, this distance diverging in the sense it keep increasing the distance. Okay, if this is our ray object here, object here, and it keep increasing distance. If you observe that distance are increasing. So they will never meet. But we are, for parallel rays, we are assuming that it will meet at somewhere infinity. So we are placing the object somewhere. So what is the position? Can you tell me the position of this object, which will give you like a virtual image for this lens? So focus will be here or focus will be here? Do you remember this? It's yesterday 10th standard. Can you recall that? Or shall I draw?
Between
Sorry. Between, yeah, correct. Between F and P. So this position of this object is between F and P. So if I place this one here, so this will get diverged. The rays will get diverged. It will never meet. So we are extending this ray to form at this place that forms magnified object. That magnified object. Okay, but this was object somewhat height. So if it is a small, tiny, so it will form image somewhat little bit visible type. Okay, this is what a drawing was about. Same thing, like you already studied this thing. It's very, very easy. All this chapter is like very easy. Excuse me. Okay. So this is the height of the object, and this will get the height of the image and distance of the object. Okay, my internet got stopped. Yeah, okay, yeah. This is distance of the image, which varies from 0 to infinite. It can be any number, okay. So magnifying power, theta by theta naught. So theta is your h by v, or h1 by v. So h1 is your, h dash is your image, and h by u. So it's like a, sorry. You're studying here in textbook like a height of image by height of object equals to v by u. So it just cross multiplied here. It's formed here, nothing big here. So don't get confused with these terms. It's just variables. Height of image by height of object equals to
theta naught.
Theta naught will be for this here, this one, the bigger one.
Okay.
So this is just a variables. Yeah.
So where is theta naught from? Can you repeat?
It should be this one here.
Okay.
No, wait a second. This is theta, so, and theta by theta naught. Yeah. Distance. So this is your distance to infinite, some distance to infinite. Okay, fine, that's correct. Okay, so magnifying will be your d by u. Will get cancelled, right? Yeah. Okay. Okay, if image is at infinity, so if images are infinity, so u will be equals to focus. Yeah, that we know the rule, right? If we form an image at infinity, so object at focus, image it will be at infinite. It will be parallel rays. Image will be at infinite. So your u will become f here. So your formula will be d by f. If image is at d, d means your near point, somewhat like 25 centimeter. Near point is your 25 centimeter for normal human eye. So here it will be your magnifying power will become 1 plus d by f. There is also like they will not mention directly near point or like that. They will mention with some other name. It is like least distance distinct vision, LDDV. Yeah, it should be like that only. So, least distance of distinct vision. So mostly they will say like image object is at somewhat like LDDV, or image is at somewhere found to be at least distance, that is. So we have to use D as a 25 centimeter. Your D is now 25 centimeter. That is minimum distance, we can say. Minimum distance human can see or required. So minimum distance and the maximum distance, that is far point is infinite. Near point is 25 centimeter. So keep this in mind. It might be mentioned in your book or not. It might not be. So just keep in mind these things, these words. Sometimes they're using like this least distance DDV, LDDV. That means they're talking about least distance. That is 25 centimeter. So other name is your near point, far point. If you made a note of it, we can move to next. Shall I scroll down? Right fast because like there will be maths class also next. Done?
Yes, sir.
Okay.
Yes.
Okay. Super. Thank you. Chalo. Compound microscope. So here what we did, we just magnified one time. Let's assume that 10. We got magnified here. What if we use one more lens? Where is our eyepiece? Here, it's not drawn, so let me draw here. So we got image here. Okay, now this will be the object for this eyepiece. This is your objective lens. This is your objective lens. This is the image for objective lens. This is the object for objective lens. Now for eyepiece, see eyepiece means we are looking from here. Okay, we are looking from here. That's why it's called eyepiece. So it will be magnified here again. Now let me do this one bigger. See, understand one thing between, there is some difference between microscope and telescope that you have to tell me. So I'll explain this one, then what is the difference in that you have to tell me. See, in this one, in this case, what we are doing here, we are magnifying. This objective lens will magnify somewhat, let's take 10 times, assuming we are assuming 10 times. And this eyepiece, it will magnify for eyepiece, and eyepiece will magnify to us. So again, it is magnifying 10 times. It will become 100 times magnified object. We can see, okay, bigger image of the, like a microscopic view of some cell or some, whatever it is, cell division or whatever it is, whatever we are doing, using for in your laboratory. Fine. Now, what is the function of telescope? Here we are using big size because we want that image. See, this object is somewhat smaller. We want this eyepiece at focal length should be so high. This focal length should be so high so that it can capture the whole image properly, and it can magnify. Okay, so it is not so high in a sense, not like room size. I'm not talking about room size, but yeah, it is bigger than, like we can say, triple size of this one. We can say that. Okay, that is the function of this eyepiece. Now, what changes should I do to get telescope with the same? In telescope also we will use same both things. Okay, but what is the function of telescope now? What changes should I do here? First, you understand what is the function of telescope and what changes. should I do these things to get telescope? Can anyone tell me? Can you try at least? It's okay, right, wrong, doesn't matter. What changes should I do here to make a telescope? And what is a telescope? Just give a little idea that how much you know. Come on. Then we can continue these things later on. That's okay. But you tell me, what is a telescope? Like at least something, some points about telescope, something 1 point or half, some 1, 2 point, 3 point, half point. Doesn't matter. Yeah, tell me.
Far away objects from a telescope.
Yeah, it's a function of telescope to make it far away object, to see the far away object. Yes. So in this compound microscope, what we did, we magnified, we brought the image in bigger size. Okay. So what changes should I do? Okay, no problem. You think and tell me tomorrow. What changes should I do in these two lenses? Okay, you think and tell me tomorrow. We'll discuss that.
Okay.
Yep. Bye-bye, everyone. You have to go for next class also. Yeah.
Thank you.
Yep. Bye-bye.